is our third presenter, is Dupont Ma from the University of Southern Denmark. He will be presenting his paper on business models for digitalization, enable energy efficiency and flexibility in industry, a survey with 9 case studies. It doesn't work.
Well, thank you for your introduction. I'm from the University of Southern Denmark, and the 2 other co-authors, Michelle and Monod, they are from Natural Resource Canada. And in this paper, we do a survey of 9 cases of different digitalization tools and analyze their similarities and differences and do some analysis. This is the agenda of my presentation. I will introduce the motivation and objectives, some related work and background, and the methodology of the study, the results, and the conclusions. In 2021, the European Union published some statistics about the different the energy consumptions of different industrial sectors, and it shows that the industry sector, especially the industrial processing sectors, contributes for about 25% of the energy consumptions. So it's very important to find some solutions to reduce the energy consumption in industrial processing domains. To cope with the global climate change in industry, there are 2 main challenges. One is to improve the energy efficiency, and the other is to improve the energy flexibility. And in Industry 4.0, there are many different kinds of digitalization tools that can be developed and applied to solve these challenges. And in this paper, we use a business campus to documenting the different cases which are collected by the questionnaires in the different domains and with different value propositions, and then we analyze their similarities through the value blocks in business model canvas, and try to make some recommendations to develop the high quality digitalization tools in industry. There are the definition of energy efficiency and energy flexibility in this study. In this study, the energy efficiency represents the capability of decreasing the energy consumptions, but still maintain the production quality. And energy flexibility represents the capability of an energy system to adapt its energy production or consumption patterns to in response to fluctuations in energy supply or demand conditions. There are a lot of different kinds of digitalization tools in industry now. Machine learning algorithms can be applied to analyze the large-scale big data in industry. In Internet of Things, is used to record the key variables in industrial processing by such sensor networks. The digital twin is applied to simulate the industrial processing and optimize the processing to improve the energy efficiency and the energy flexibility. And cloud computing is used to store and to manage the industrial big data. This study use the business models to analyze all collected cases. In general, the business model describes how an organization creates, delivers, and captures values in economics, social, and other domains. But in this study, we use business model canvas to analyze the industrial digitalization tools. It is used to representing key value blocks and documenting them in different categories, so as to provide a systematic overview of industrial digitalization cases, and also to evaluate the digital solutions and make some recommendations based on the comparison of different cases. This is 9 key value blocks of business model canvas. This study collected the data through questionnaire, and the objective of the questionnaire is to collect the essential information of different cases by both industrial sectors and the IT technology providers. And the questionnaire includes 4 different sections. There are basic information, technology development, some market questions, and some other value delivery. And this is a business model canvas for industrial digitalization tools. And we also developed an evaluation metric or evaluation formula to evaluate the commercialization potential and the potential of real-world applications of the different cases. And in this metric, the 2 dominant dimension is the maturity of the tool and the value propositions of the tool, because they are directly influence the real application and the commercialization of the digitalization tools. Here is a case study and the results. Finally, we collected 9 different cases, and they are from different industrial sectors in different countries. And after documenting each cases in different business model canvas, and we compare them and analyze them by the different value propositions. It can be seen that there are 6 different value propositions in the 9 cases, including the improving energy efficiency, reducing the greenhouse gas emissions, optimizing the industrial processes, and so on. And for each value proposition, they have different key partners, different activities, and different customer segments. This is the results of the value evaluation. It shows that 2 of the 9 cases have the high commercialization potential, and 8 of the 9 have the medium or high potential of commercialization. So it means that most of the digital solutions can be directly used in industry, and just need some small validation and testing. After comparing the 9 cases, some recommendations for high quality digital solutions to improve energy efficiency and energy flexibility are provided. Firstly, the industrial partners and the academia partners should work together to develop the digital tools, because they have different perspectives in applications, and they should do more comprehensive testing and validation, so that the developed tools can be applied in different scenarios and in different processes. And they also need to extend the value propositions and enhancing the product adaptability, so that one digital tools can be used in different in industrial processes, and they don't need to develop the other tools. And of course, they should provide some user-friendly platforms and adopt some data transparency, so that it's more easier for the engineers in industry to use the tools and to validate and improve the tools by themselves. Finally, to conclude, it's important to develop some symbiotic and intelligent digital solutions to guide the decision makings in industrial energy efficiency and energy flexibility. And it's also recommended to design some digital solutions that are user-friendly, transparent, and possesses the ability to maximize the commercialization potential and the application across different contexts. That's all. Thank you for your attention.
Thank you. So now we have time for some questions.
Yes, thank you for the nice presentation. I was wondering why or what the reason for the specific weighting of the different factors of the business model canvas you have chosen. Like I noticed that technology readiness level had a weighting of 1, and another factor also had a weighting of 1 before you had an equation on one of the earlier slides. Yeah. Yes, this. So what's the reason behind this weighting of the different metrics?
In the published paper, I have a detailed table to describing the scoring scale of different dimensions. The reason to give them different scores to evaluate the potential of the commercialization or direct usage in industry. If this tool in this dimension, they have less restriction for direct use and has easier application potentials, and then it can have a higher score.
Okay, thank you.
Thank you.
So do we have other questions? No? Yeah.
Yes. Can you show us this result? Because you show there's two tools quite. Notice the scores. Yes, these two are quite high. So can you explain to us what's this digital tool for these two cases, and why they have this high score?
Further, the two dominant dimension is the maturity of the capitalization and the relative benefits. In case 1 and case 5, it shows that the maturity level is high, is because they have finished the laboratory testing and have been tested in real world in industrial processes. Because in the maturity level 6 means they have been tested in simulation and laboratory scenarios, and level 7 means they have been tested in real world processes. And the case 1, the level is 9. It means that they have been tested and validated and can be directly used in industry without any validation.
Thank you all for questions.